Hi everybody, a brightful good morning for you all. Yes, a brightful good morning because today is colorful day. We are learning about the light, electromagnetic waves, all about colors we are going to learn. Here you see different colors. Daily in our daily life we see different colors. We have our favorite color. My favorite color is white and black, yellow, red, green, orange, purple, brown, everything. So okay, here finally a red color. The red color has some importance in our life. It's not only a color; it serves many important role in our life. Here are few examples for you. In the advertisement sector, we use the red color so that it is so catchy for the people to attract, and we use this for alert. If there is any alert, there will be a red, right? And the signal to stop, to start, and everything is about colors. And then red to stop, it indicates. And then flight, you can see the flight at the edge of the tail. You can see the red color even from very far. You can see red color. Why they are using red color instead of violet, instead of blue, instead of green? They use red color. Why? What is the reason behind? You see the mobile tower, you can see from very far the color of red and mixed with other colors. You can see, but you can see the red color, right? And the top of the tower will be a red light. Night view, you can see there is a tower for the flight. They can see the tower's red light. It is very far, even it's very far. You can see the red. And notice board, to attract the people, we use the red color, right? The notice board, school notice board, office notice board, everywhere there will be red color if you notice. And then we are using the red color for the highlight important points, right? And many uses of and properties of light. And then this red is coming under light. We know the light, sunlight is composite light. It is a white light, which means it does not have only one color. It has seven colors, the mixture of seven colors. That's called vibgyor: violet, indigo, blue, orange, yellow, red. Okay, so it is actually electromagnetic wave. Light is an electromagnetic wave. That means it has the electric property, at the same time the magnetic property, both, and travels in a straight line. We know that, right? And light is an electromagnetic wave. Like we have the other waves in the electromagnetic wave. Not only the light, the other waves are radio wave, micro, infrared, ultraviolet, X-ray, gamma rays. All these waves have the same speed as well. Every waves have the same speed. What is the speed value? P 0.0000000. That is 8 zeros meter per second. If you want to know in kilometers, 300,000, which means 3 lakh kilometers travel per second. Just think, 1 second the light travels 300,000 kilometers. If we know the time taken of the light travel from sun to earth, we can find the distance between the sun to earth, isn't it? What is the formula? Distance is equal to speed multiplied by time. Speed is, what is the speed of light? 300,000 kilometers. Multiplied by the time, you can find the distance, right? Okay. So, and then vibgyor, that means it is inside the light. There are seven colors. The white light has seven colors, right? As I told, vibgyor, you can see VIBGYOR. Okay, in this we have to notice something important, that is called wavelength. The violet, the first one, the first color is the violet, which has the least wavelength. The red has the highest wavelength, and speed of all the colors are the same. Okay, have you ever noticed the flags? You see the UAE flag, it has a red. Maldives, red. India, red. Some kind of orange mixed. China, red. USA and England, every flags, they, most of the flags, most of the countries, they have some part of red colors, because it is brain coordination. We can easily memorize the colors, and the highlight, we are the noticing the point, we just important points to note. We are using the red color to catch up. It is a catchy. And what are the other reasons? Notice most of the country flag, they opt red. It is because everyone can see it. It's catchy. It's something related to our brain memory coordination. It is because it higher wavelength. We knowingly or unknowingly use higher wavelength colors to highlight any important points. You can reduce your car speed from very far. As you can see the red light easily, because it has higher wavelength. That is the very important thing here. The red has what? Higher wavelength. The blue light, violet light has the lower wavelength. So what will happen during the sunrise and set? Sun is very far from earth. So if you see in the morning time and the evening time, the sky is red, orange, and yellowish color mixed. But at the noon time and the other time, it is almost sky blue. We say blue sky, sky blue, right? Because the noon time the sun is closer to the earth, so all the seven colors will not split. But if it is very far and the like morning and the evening time the light splits, because of there are lots of disturbances, clouds and dusts are there, so it splits and then it's scattered off. But the red light, as it has the higher wavelength, orange light, as it has the higher wavelength, it can reach to the eye. So we see the morning and the evening sunset time the red in color. Okay, then you can see this is the sunset and rise time the color, right? And then there are some colors after, other than these colors vibgyor, we have ultraviolet and infrared that we cannot see, because of higher wavelength and lower wavelength. We have certain limits of wavelength that we can see from our naked eye, like vibgyor, and below V it's called ultraviolet, which has the least wavelength. And then above red is known as infrared. We cannot see, that is above the red color, that is the highest wavelength, higher than the wavelength of the red, right? Okay. And you see here the reflection and filter, some other knowledge for use. And then there's a motorbike tail light, the rear light. And then how it function, some car, and then they don't have inside the light, they have the mirror inside. So you can see the mirror here inside, like I have drawn like M. So the light from outside enters in, and here is the first reflection. Because it is a mirror, it reflects the light, and this is the second reflection, the light comes out. When it comes out, here you see the filter is the almost red filter for the danger light. So the white light, all the six colors are absorbed, and only red light is coming out. That is called, we call the outer cover, the case is called filter. It fills the filter the light, and then it sends the red color, right? Okay, the next is light and sound. We knew in our daily life we see first the lightning, and after some seconds we hear the thunder sound. Why? Because the speed of light is very fast, very high, but the speed of sound is 330 meter per second only. That means in 1 second the sound travels 330 meters only. That means in 3 seconds it almost travels 1 kilometer. By the time the sound is being absorbed by the wall and the trees and the surroundings, and then you cannot hear the sound because the energy is not there. That's what the people, they use the loudspeaker. The police use loudspeaker to increase the energy. Amplitude means increase the sound, the energy of the sound, so it can travel for a long time, long distance, right? Okay, now what is the reason? Because I told lightning first and the next the thunder. Why? Because of the speed of sound is less, right? And then here we have some calculation. First we see the lightning, then we listen the thunder. After 2 seconds, how far away from you did the lightning produce? Where is the lightning away from you? How do you calculate? Here is the calculation: speed into time. What is the speed of sound? I said 330, multiply by 2 seconds. It takes 2 seconds. First you see the lightning, second you hear the sound, the time delay is 2 seconds. Just you multiply by 2, 660 kilometers away from you the lightning was produced. And then here I said what is wavelength, right? So you see it's like the wave is like a sea wave. Here is the up, here is the down. So up is called a crest, down is called a trough. So here is the red light is a higher wavelength, so it covers a longer distance. And then blue, it covers a shorter distance. The one wave has one crest and one trough. Here the blue has one crest and one trough, and this is shorter and this is longer, right? Okay, so next here is the wavelength for the red and blue. And the use of electromagnetic waves, here the radio wave. The radio wave has the antenna, and then the transmitter antenna and receiver antenna. The antenna transmit the radio wave, and the another antenna is receive the radio wave. And where we are using this radio wave, all the waves are having different uses. Like a radio wave is used in the TV and radio broadcasting, and then toy car remote, and the microwave. The next wave in the electromagnetic waves, then microwave. What is the use of microwave? It is used in the satellite communication transmission. And then microwave oven and infrared radiation. We have some use of infrared radiation. Remote control we are using, and security alarm, and night vision, and photography. We can use ultraviolet fake currency detector. What are the another use? It kills the bacteria because it is higher energetic wave radiation, and it can find the fake currency, and it sterilize the medical equipment. And what is the X-ray? It's the next after the ultraviolet, and it is more energetic than the ultraviolet. It can detect the any crack in the metal pipe. And then under the ground there is a metal pipe, lots of metal pipe nowadays, that can, if there is any crack, the X-ray can find out. And that is a metal detector X-ray. And scanning machine in the airport, we are using the X-ray. And X-ray to take the bone fracture photograph. And then gamma rays. Gamma rays is used as a chemotherapy for the curing cancer. At the same time, it causes cancer also, right? If it is a small amount, small dose of gamma radiation can cure the cancer cell. And the next is penetrate almost all the metals, and it cannot be stopped by, can be controlled by lead. And a thick concrete can it cannot penetrate it. It will penetrate, but you can reduce the amount of the gamma rays. Next, there are the few things that we learned today about the colors. And red is catchy, can see from long distance, we learned. And sunrise and sunset, white is a yellow and orange color, and violet scatter off. Danger light reflects light, and filter allows red, or a type of filters we learned. And we learned about compare light and sounds, the speed of sound and light we compared. And we learned about something about the electromagnetic waves and uses. Isn't my friends? So you see here we use the red color. I think most of the occasions we use red, because it is catchy, and it has the higher wavelength, and it has the higher speed, so it reaches us. And then here the audio, you have listened my audio, sorry, video. And please like and subscribe. And then I like your continuous support. Thank you very much, my dear friends. Thank you. Thank you.